Hello and welcome back to another episode of Your Prescription for Tech Nonsense. Due to tremendous request, I'm going to be rehashing a previous video where I tested to see if the operating system Bazzite, a distro of Linux, could save a 4-core CPU in the year 2025, especially with Windows 10 rapidly approaching its end of life. And at the same time, I'm going to be seeing if Bazzite can offer a potential boost in performance comparatively to the mainstream option Windows. For our test, I will be using the same processor as my last video, a Ryzen 3 Pro 2200G, which features 4 cores with no hyperthreading and a 65-watt TDP. Our system will once again feature 16GB of 2400MHz RAM and dual channel to simulate what is likely to be found paired with an older CPU and to ensure no variance from the previous video. Now I want to take a second and say thank you for all the support on my last Linux video. That video by far was my most popular and garnered my channel over 100 new subscribers. However, like anything that's popular, it also comes with criticism. The biggest point of contention on my last video was that I used this, an RTX 2070 Super, which is an NVIDIA GPU, to do my comparisons between Windows and Linux, which some viewers felt was unfair. So after taking the many viewer opinions into consideration, such as AMD graphics cards providing more headroom for older CPUs, and that Linux tends to work best with an AMD graphics card, I went onto Facebook Marketplace and purchased this, an RX 6700 10GB. This card is part of the Navi 2 generation, which was built on the 7nm process size and features 2,304 shading units, 144 TMUs, 64 ROPs, 36 compute units, and 36 RT cores, with a 175-watt TDP. I chose this specific card for two main reasons. The Navi 2 generation is recent enough to have modern features, but has been out long enough to have solid driver support from both Linux and Windows. The second, more important reason is that this graphics card is neck and neck when it comes to rasterization performance comparatively to the RTX 2070 Super, which is the card I used in the last video. Now, it has been touted time and time again that AMD offers increased performance on Linux due to better open driver support, improved compatibility with Wayland, and AMD's affinity for Vulkan optimization. So this graphics card should allow us to see once and for all if Linux can save our 4-core friend, or if Windows remains dominant even with Linux savior, the AMD GPU. The first test I will be running is Time Spy on 3D Mark. Unfortunately, I cannot run this on Linux, but our score will help us compare to the previous system with the RTX 2070 Super that I used in my last video to see if there is truth that older, less capable CPUs perform better with AMD GPUs due to increased headroom comparatively to NVIDIA. Now, our results here show a 10,849 on the graphics score and a 2,686 on the CPU score. If you take a look at the results, you can see that the NVIDIA system actually resulted in better performance from the 4-core Ryzen CPU with a score of 2,858. Now I will say this is probably just within the margin of error, as I did run Time Spy more than once, which resulted with scores from the AMD system in the 2,700 region, but this still does call into question if these CPUs are really getting a meaningful performance improvement with an AMD GPU, like some of the comments on my previous video suggested. Now enough about the AMD versus NVIDIA nonsense, it's all Windows versus Linux from here on out. In an attempt to be more objective and analytical, I'm adding in Unigen superposition, which can be run natively on both Windows and Linux. This test will be run at 1080p medium with the OpenGL API. This test ran well mainly in the 130 FPS range, but did have a few drops below 100 in the more intense scenes. And as you can see, this resulted in a final score of 16,601 here on Windows. Moving into our first game, Rocket League, this was run at 1080p high settings with no motion blur or light shafts. This game ran fine with no hitching or stuttering. Honestly, it sat around 150 FPS range the majority of the time and was really the only game that wasn't absolutely maxing out our CPU. Now once again, in an attempt to be objective about performance, I've done some actual performance benchmarking. However, because I can't use the same FPS monitoring tools on Windows versus Linux, I'm introducing an unwanted variable in this comparison because I can't guarantee exactly how much demand each program puts on the CPU comparatively. Now, the program I chose for Windows was Fraps, and for Linux I ended up using Mango HUD. Now, looking at our Fraps data for Windows, our average FPS in Rocket League was 165.94, and the minimum was 105. Moving into Counter-Strike 2, a more CPU-demanding game, we will be running this game at 1080p high settings with anisotropic filtering set to 4x. This game was playable, but really didn't feel great for a competitive experience. The game sat somewhere in the 60 FPS range the majority of the time, with excursions into the 70s. However, the dips into the 50s and below are what made the game feel rough on the surface. Unfortunately, I could not get any Fraps data with this game since I can't use an overlay and play online. Now, in spite of that, I downloaded a benchmark workshop map, which we should be able to use on Linux as well and get a direct comparison in a game that is both native to Windows and Linux. The Dust2 benchmark map is a nice inclusion, but I don't think the numbers it produces are completely in line with what you would see in-game. Benchmark recorded an average FPS of 119.1 and a 1% low of 76.6. Those numbers feel much higher than what I was actually seeing during gameplay, so take them with a grain of salt, but we can still use them to compare with Bazite later. Moving into an even more demanding game, Elden Ring, the game was set to 1080p all high settings with motion blur turned off, and honestly this experience felt totally playable. The game sat right around 40 FPS with some dips down into the 30 FPS range, but overall the game was stable. The Fraps data provided an average of 41.65 and a minimum of 27. Mind you, I tested in one of the most graphically intense areas of the game in order to show the worst experience possible. Now, the game runs better in other areas of the map and is completely playable. And if you don't believe me, here's footage of me accidentally beating a boss in the DLC. This area of the game ran in the 40s the majority of the time, and after the boss was defeated up into the mid-50s. Moving into Cyberpunk, a game known for its graphical intensity, this game was run in 1080p with ray tracing turned off, crowd density set to low to give our CPU the best chance, motion blur off, and a mix of high and ultra settings. Mind you, all game settings being used here on Windows 10 will be kept exactly the same when I do my Bazite testing later. This game felt somewhat playable with FPS around the mid to low 40s range, with definite dips down into the 30s, and moving out of the city would push the FPS closer to 50. Now, the Fraps data provided an average of 46.04 and a min of 30 FPS. Cyberpunk has a built-in benchmark which I ran, but at the time of editing this video, I'm realizing that I never recorded it on my capture card, and despite that, I did actually write the results in my notes. It produced an average FPS of 63.4 and a min of 46.75, which once again just doesn't feel reflective of the actual gameplay I was seeing. But now, it's time for our Unreal Engine 5 Buzzsaw, Oblivion Remastered. This game was set to 1080p medium, with both ray tracing and motion blur set to off, and FSR set to balanced. Now, reminder, this game does warn that it requires a processor with 6 logical cores to perform appropriately, so the experience this game produced was definitely not perfect. The game sat around the low to mid 30 FPS range, but suffered significantly from drops and stutters. The recorded Fraps data showed an average of 34.29 FPS with a min of 3, which elucidates the exact stutters that could be felt while playing. But now, the question that you have all been waiting for: will Bazite save this underwhelming CPU and boost the PC back to gaming glory, or will it come up short of the improvements that I have heard so much about? After a quick install of Bazite, it was time for our first Linux benchmark. Starting off with Unigine superposition at 1080p medium with the OpenGL API, this test is a nice comparison because it runs natively on Linux, meaning a compatibility layer would not interfere with its performance. This benchmark ran decently, but it felt like the FPS was sitting much closer to the 100 to 110 region the entire time, which is about a 20 to 30 FPS drop comparative to Windows. Now, this performance decrease is reflected in the overall score this benchmark produced. The final score for this system was 13,958, which is almost a 3,000 point drop comparatively to Windows. This opening mark does not look promising for Bazite. Jumping into Rocket League, our first game tested on Bazite, I was shocked to see that it was running at about 90 to 100 FPS. This is a huge decrease in performance from what was seen on Windows. The game actually felt like it ran somewhat better when I ended up running Mango HUD in unison for some reason. You can see some of that footage on screen now. However, the Mango HUD data showed the game FPS average was 126.3 with a 1% low of 68.4 and a 0.1% low of 45.1, which is still a significant decrease from Windows. The trend for Bazite doesn't look promising so far, but maybe a Linux native game can save it. I think that hope was short-lived though when I loaded into Counter-Strike 2. This game ran terribly, and maybe it's just me, but it always feels that Counter-Strike 2 is just a little worse on Linux than it is on Windows. Here I was seeing frame rates in the 40s and 50s, with FPS hitting 60 on a special occasion. Since I can't record FPS with Mango HUD while online, I ran the Dust 2 benchmark again, which provided an average FPS of 85.6 and a 1% low of 62.3 on its best run. Once again, these numbers feel inflated from what we were seeing in actual gameplay, but are still significantly lower than what I saw on Windows. This trend really does not look good for Bazite right now. Moving into Elden Ring, I knew right away that our performance was continuing down the same unfortunate path. Elden Ring just felt worse here in Bazite. The FPS dropped closer to the 30 FPS range, and had stutters simply from dipping down into the 20s. Mango HUD showed that our average FPS was 27.3, with a 1% low at 18.9 and a 0.1% low of 15.1, which once again was just worse than Windows. Much of the same performance loss was seen in Cyberpunk, with an average FPS of 38.2, 1% low of 18.94, and 0.1% low of 16.18. The dips in these games just made them feel so much worse. The built-in benchmark once again reiterated the performance loss I was seeing, with an average FPS of 58.69 and a min of 44.08. Unfortunately, the same fate was seen with our Unreal Engine 5 game, Oblivion Remastered. The average FPS was 22.2, with a 1% low of 9.93 and a 0.1% low of 2.63, which is just unfortunate for Bazite, especially because I want these Linux systems to be real alternatives to Windows. So while these results I have shared haven't necessarily been positive, it's not all doom and gloom. If you remember correctly, the initial reason I did this video was to see if I could save an older CPU with Linux. So I ended up performing a CPU-only benchmark in OCCT, which runs natively in both Linux and Windows, and I think these results might surprise you. Our aging CPU had a performance improvement in single-core and multi-core tests of both SSE and AVX instruction sets in Bazite comparatively to Windows. I ran this test multiple times on both Windows and Bazite to ensure it wasn't a fluke, and every single time, the Linux distro outperformed Windows. This almost confirms my hypothesis that the deep-loaded software of Linux is beneficial to older CPUs. However, if this is the case, then why did I see significantly worse performance in the synthetic and in-game benchmarks, with even worse performance in the actual games themselves? Now for the record, I let the pre-caching of shaders fully complete before testing any of the games on Bazite, no matter how long it took, in order to avoid any sort of bias. So what could possibly have been causing this decreased performance? My personal opinion is that whatever graphics driver Bazite is using currently on Edition 42 is not as good as the specific Windows driver at this time, which is definitely a limitation of using an immutable distro like Linux that has the graphics driver baked into the kernel itself. Any graphics driver updates may or may not come with individual updates to the operating system, so you're kind of at the mercy of the developers of the distro. That being said, I tried two different versions of Bazite, one of which being the most updated version, and I really did not see any performance improvement between the two. The latest version actually performed slightly worse in a lot of the benchmarks. Which brings me to my conclusions for this video. The first conclusion, and trust me, it pains me to say this, Bazite is not a guaranteed performance improvement comparatively to Windows, even with an AMD GPU at this time. Now trust me, this video is not all doom and gloom for Linux. I personally want Linux to succeed, and the simplicity that comes with a Bazite installation still makes it a real contender for people looking to game. The deep-loaded software of Linux also definitely gives older CPUs an uplift comparatively to even a bare-bones Windows installation. Now, some of these performance issues I saw may also be remedied by other distros of Linux, including those that allow for the user to install their own GPU drivers. Personally, I plan to experiment in future videos to see if I can find the best Linux distro for my everyday uses and for gaming. My biggest takeaway though is that the more people that experiment with and use Linux, the better. Investment into a platform like this will only help continue its growth and development, but will also allow software developers to see the demand of operating systems other than Windows. If you made it this far in the video, I want to give you a huge shout out and say thank you. All of your support is greatly appreciated. I also want to say thank you to everyone who's left any comments on my previous videos, giving me ideas for future videos, as well as ways to make my videos better. That is all appreciated as well. Now, if you like my videos, go ahead and leave a like and subscribe. I'm trying to make more videos in the future. These are kind of just passion projects for me, so they come as time permits. So once again, thank you, and I hope to see you in the next one.